Oh, thank you.
Did he move us?
I got it. Don't want to brag, but I called it when you got it. Oh, the bridges. I did, didn't I? I was like, how sure this one's you? You got in, and I go, CEO, you're next.
CEO, Matthew, you're next.
Honestly, next year, or like next when we tap in, yeah. If you do it, you have to get a frisbee and take it on the frisbee. And throw it to whoever it is. That'd be awesome. CEO, I want you to like stand from the stage.
Your hands are clammy.
Why they don't come work? I'm gonna just down low. Hit you on the down low. Sure. Where are they?
Early
No.
Why aren't I here? I don't need them. I have great leadership.
It's because they picked people that already had leadership skills. Yeah.
That was what I like punching.
Avocado.
Oh, did you see this?
She will get a
Protein croutons.
What?
What?
Absolutely not. Okay, so I was calling, right? They did this Charlie thing. But once again, JMC, how the hell am I supposed to know?
Hey,
She would kind of peacock on him. And then
Why?
I was gone. I was gonna explain until I freaked out. I was gone. And it wasn't in JMC. And she expects me to do it. I was like, how am I supposed to know? And she's like, well, was it in lesson plan? I was like, no, that's my apology. Let's go and done like 3 days. I was like, how am I supposed to know how to do it?
Right here?
No. No.
Alright, hey, we're going to do a couple notes today, and then I'll give you some time, a little bit of time at the very end where you can work on your homework. Homework, if you don't remember, page 159. If you're not here yesterday, that's what we got. There's no graphing, none. All you're doing is you're basically telling me what the intervals are for domain and range. Tell me what some of the substitution values are. I'll kind of put a picture on the board here in a minute of kind of what you have to do on a certain couple of them. There were some questions this morning on it. And then on some of them, you just have to tell me maybe a min or max in a certain case. And I'll kind of show you that. But those are due tomorrow, okay? All right. These are not here. All right. Okay. Yesterday I handed out some old homework. So for those who were gone, I'll hand out some papers to you. If you noticed your grade online, I finally got it updated. Hopefully it's showing up for you. It sounded like some people definitely saw it yesterday. I've been hitting like publish, trying to get it to work. If you're missing something by tomorrow afternoon, so they can get it done. If you're gonna, the papers I hand back, you're gonna make fixes. Make a fix, turn it back in. I can grade it. If you notice that when I handed back the paper and it was like missing the grade book, but you have it in your hand, turn it back in. Maybe I just skipped it. I had one person yesterday that happened to them. So, all right. Seeing arrangement. Who are we missing today? Anyone? That's good. All right. Okay. But let's actually go through a couple notes here. I'm going to pop up the picture from your homework yesterday because I do want to discuss it. I don't want to leave hanging on it. Because there were some really good questions on it this morning. All right, so there we go. All right, so this was all right. This was like one of your problems you had in your homework yesterday. I believe it was what 55 through 59. Somewhere in that range. And the question was like you had to find certain values. So on this function, it was f of x. If that's the function, you can see it's labeled. It's kind of going up and down. And they ask you a series of questions like, what is f of -1? So what that means is you've got to find -1 on the x-axis. That's your x number. And then what you're going to tell me is the y number that's getting spit out. So So here's -1 on the x-axis. What number is on the graph here? What number is that? 0. That's your answer. You move on to the next one. Okay. If it asks for f of 2, you find 2 on the x-axis. And now it looks like 2 is down here. What would that number be? You get 4. That's your answer. Does that make sense? Like what you're doing? Now I know I think there was one problem that said, no, I don't know if it was on this particular problem or it was a later one where it said f of x and it said, find out when it's 3. F of x equals 3. Well, if it was on this particular problem, they want to know the x number that will spit out 3. There's actually a few of them. Okay? So when it will spit out 3, 3 is right here. This is 3 on the y-axis. There is a bunch of them that will spit out 3s. Does everyone see that? Like going across, it will spit out 3. So there's like a bunch. There's -4.5, -3.5, -0.5, +0.5, 3.5, and 4.5. So there's like 6 different answers there that will spit out the number 3. So that's a different situation. That's when they're looking for a certain x value that will spit out that y number. That's kind of like an inverse operation. Okay, questions, comments on that first one? I just want to kind of show you that because the next picture is, I believe it's the 66 through 76 problem. All right, so let's copy that picture up here. And it was this one. Okay, correct? That was your 66 through 76? Okay, all right. And one of the questions, it was just one in particular. This is the one that I got this morning by somebody. What is f of 10? Or g of 10, sorry. G is the right letter. G of 10. That's a good question because 10's not on that chart, correct? Keeps going. So what will the answer be? Yeah, the answer down the road, so wherever 10's at, 10's down here, 4, 5, 6, 7, 8, 9, 10. This is your answer. Right here. It's -2. I had somebody tell me this morning, well, is it like positive infinity? No, because you're looking at the value for the y numbers. Infinity is at the top, like way up, and it's not. You're looking at the y value, which is -2. That's the number that you'll hit because it's a horizontal, it's a constant number from the rest on. Okay. So that's the idea. It was just I understand their logic. They were thinking about like x numbers, like the arrow's going towards infinity, but the actual y answer is what I'm looking for. Okay, does that make sense? To help you out a little bit? It was a really good question somebody walked in this morning and asked me. I just want to make sure we covered it so you didn't make a silly mistake. Especially if if they're asking for certain numbers here, if they ask for to plug in -3, you can use halves. It's fine. So if I ask you to do g of -3, that number is going to be 1.5, or you guesstimate the best you can. So that's fine. You can get decimals. Okay. I just wanted to cover that. I thought that was just kind of interesting. Our topic today, because we're going to do a few things today. I want to discuss. So we're going to be moving on to section 1.3 here. We're moving on to instead of doing domain and range for functions, what we're going to be looking at is symmetry of functions. Symmetry. That's a new topic today. Now the best part is it goes really nicely with what we've been learning. It's nothing like crazy new, but it does have some topics that we just need to discuss. We need to go over it. And I'll kind of use the pictures that I talked about here. Again, it still talks about maximums, it still talks about minimums, relative and absolutes. But there's a couple new topics. So number one, the first topic that we're going to talk about in this section, increasing, decreasing, and constant functions. So we're actually talking about the functions themselves, whether they're increasing, decreasing, or they're staying constant. how you explain it to somebody. So like on this particular picture, the one I have up here, it actually appears, that picture is constant for certain intervals, and it's decreasing from left to right. It's decreasing as we go left to right in the middle. Does everyone see that? So like generally it's going down. Okay? But the outsides are constant. Okay, so we're going to talk about that. That's one of the topics we need to discuss. The other topic is this idea of symmetry, which is, this is the main topic we're going to really discuss today, is even, odd, or neither. Neither, however you want to spell it. This is going to represent the actual drawing of the function itself, not just not the intervals, not just the general trend. It's actually talking about the drawing, even, odd, or neither. This is the actual symmetry of the drawing. The sketch. That's right. We're going to talk about that. There's a little simple rule we do for functions to check whether they're symmetric. All right, and the last topic I don't know if we're going to get to it today. This might be a topic for Friday. I do want to talk about slope in general. Just slope in general, just to make sure that you understand how to find slope and what slope is. That's one of our main topics for functions, because it has some severe importance for later on. So I don't know if we'll get to it today. We might talk about it tomorrow. But does everyone understand our goals today? What we're going to talk about? Pretty easy. Once we get through these, then I'll give you some time where you can kind of the stuff I gave you yesterday. Should be nothing like crazy new. It's pretty straightforward, especially this interval stuff with the first part. And then we'll talk about this even, odd, or neither idea. Let's do a few examples. We're out of here at 10:44. About a half hour. Yeah. Okay. All right. Let's start with this graph here. I'm going to use the same picture and then I'll go back to the last one. I want to talk about this increasing, decreasing, or constant function. So what I want to describe is like the overall trend of what this function is doing. So I want to talk about the intervals, whether it's increasing, decreasing, or staying constant. So we're going to use interval notation. This will give you a trend on your data. Like, is the function overall decreasing as you go left to right? Or is it increasing, or is it just staying flat? That type of thing. And obviously, like, this picture is deceiving because if you were to zoom out, like, far enough, everything would look flat. Like, you wouldn't notice this little taper. If I zoom in really far, what does it look like? It looks like it's decreasing, right? It's going down. So graphs can be deceiving. That's something you need to realize from, like, polls and stuff that they put in newspapers and media. You need to look at the scale for the drawing. It's a little deceiving, especially if you zoom out really far. All right, but intervals. Let's talk about when it's increasing. Does this graph increase at all? Does it go up to the left at any point? No. So increasing, it does not apply. It's non-applicable. There's no increasing to this graph. Does it decrease at any point? Yes. And that's now we have to put the interval where it is actually decreasing. So for the interval, we start here and we're going to here. So again, when you do the intervals, you're giving me the x-axis numbers for that. Don't give me the y-axis numbers, give me the x-axis numbers. So when did it start decreasing? -4 to when? When did it stop? 2, and we include the 2 because they're solid dots. That's the interval that we're decreasing. Does that make sense? Why did I use brackets? They're included, right? They're dots. They're solid. They're open. Why didn't I do some weird intersection or like a union with this thing? It didn't stop, right? It took a different slope. It took a different turn, right? It's got a different tilt to it, which is slope, right? The actual rise and run change. But it was overall, it's still decreasing. It's still going down, just maybe at a different rate, different speed. But that's an interval, okay? Now, is it increasing or not increasing, but staying constant at some point? Yes. So we are staying constant. Okay, where is it staying constant going left to right? Negative infinity up to 4, right? So negative infinity up to the number 4. We're going to include the 4 because there's a dot there, right? So it was constant there. And then we're going to do a union, and where does it, or not 4, negative 4, sorry. Negative 4, sorry. And then we're going to do a union because it looks like it's decreasing, so that's not constant. And then you got to here, and now it's staying constant again, correct? So that's what? 2 to positive infinity. That's the interval in which we're actually staying constant the entire time. Okay, does everyone notice I use parentheses for the infinity symbols because that's not a number, it's a direction. I use brackets for the numbers we included, they're whole numbers, so they're actually included, they're solid dots. And I did a union because at some point there was a gap. This was decreasing, so I had to skip all the decreasing part. Okay, does this make sense? The idea of that. Okay. So that's a big one. Now, let's go to another graph. So this is just one graph. I want to show you some examples of that. Let's do another graph, and then what we'll do is we're going to come back and talk about symmetry. That's what we'll do at today. Okay. All right. Let's go to a new picture here, and we'll do the exact same thing. All right. Let's go back. In fact, let's just go back to that last picture. This one. That's good. All right. So. Increasing. So increasing. Is it going up at any point from left to right? Yes. There's actually quite a few of them, right? So it's actually increasing at this interval from this number here up to here. In this little band, it was increasing. It was going up, left to right. It was going up. Did it increase from here and on? No, until it gets to right about here, it starts increasing again until it gets to here. It's going up to the left. Then it stops, it starts going down again, and it starts increasing again until it gets to here. And then it decreases after that. Does that make sense? Like those are the bands where we're increasing. But how do we write that as an interval? So let's talk about the interval where it increases. -5 up to -4. Brackets, right? We include those numbers. They're solid dots here. Union. -2 to 0. Union. And then when are we going on? 2 to 4. And notice I'm using brackets the entire time. So I was using brackets, I'm using the union symbol because there's spaces, there's gaps between. So I had to use this idea of the actual brackets and the unions to skip over the parts where it's decreasing. Okay, any questions on any of that so far? I'm doing that. Now if there's any open circles, if there's any open-ended parts, we'll put that. We can put that in there. We can put parentheses on it. But for me, I was going by. There's no holes in the graph, so we don't need to worry about it. Okay, what about decreasing? Okay, so it decreases -4 to -2. Union. So it went down from here to here. What was this? 0 to 2. The first decrease. 0 to 2. And 4 to 5. Now, why we write it like that? Why interval notation is because we're including all the numbers in between. All the numbers from -4, including that number, all the way down to -2. We included it. That's x-axis numbers. I'm doing this. The reason why is this is a solid line, so it can include all the decimals as well, in between -4 to 2. And then here, same thing, 0 to 2. And then 4 to 5. Yeah. That's basically the best way you can put it. Some graphs there'll be breaks in the graphs and stuff, and so we'll have to worry about like the parentheses versus brackets. But these are the two graphs I picked today. Is there any constant functions on this one? No. At no point did it ever level off. It never just plateaued it. It was just going up and down. So it's not applicable to the constant function. Okay. We feel comfortable with this. Okay, now, this graph, obviously, is going up and down. It has a maximum. What's your maximum number? 4. Minimum number? 84. In fact, those are the absolutes and the relatives as well. They're the same. Absolute because it's the tallest, highest point, but there was also multiple heights to it. Like there's multiple hilltops. They're all relatives, but they're all the same absolute maximum. And the same with the valleys. We don't use these as relatives because there's nothing to the right of this one. There's nothing to the left. Remember, relative minimums and maximums, they have to have numbers to the right and left of it. So that's why that's a maximum. The numbers to the right and left are actually lower than that. Does that make sense now? Like how you do relatives? Absolutes like the 12th one. There's a couple. There's one number for absolutes. Okay. That's pretty much about it for the increasing, decreasing. Let's talk about this symmetry idea. Let's talk about symmetric. All right. So how do we know a graph is symmetric? So let's talk about this first type. We're going to talk about symmetry. We're going to talk about even functions. Okay, now what we call an even function, just so you know, is called y-axis symmetric. So y-axis symmetric, that's the term that your book will tend to use. Okay, what that means is that when you look at the picture, there is some exact perfect symmetry versus the left and right side of the y-axis. This is the y-axis, right? It has perfect symmetry this side and that side. They're like the perfect mirror images of each other. So, so the idea is that, you know, like on that picture right there is symmetric. It's y-axis symmetric because the left and right side are exactly the same digits. So how this works, how you can check like visually, is no matter where you're at on the graph, if you pick one of the positive numbers, okay, if I pick the positive number over here, so let's say like x-axis, I pick the number 1, and you go over here to -1, and it gives you the same number spitting out, like same digit across. That's y-axis symmetry. That's y symmetry. That's what they call it, y-axis symmetry. Okay, so it's an even function. Now, how we can test that graphically is easy. It looks the same, left to right side, like that picture. How you can test it if you have a function, like an actual equation in front of you, and you're not graphing. How you can test this without looking at a picture. Right? This is not the same picture, by the way. But how I can test this is, here's how you do it. So instead of the y, you're going to have a f of x. That's the name of your function, right? That's what we've been doing lately. What you're allowed to do is it's called a symmetric test, symmetry test. You plug in a negative x in your function. So we're going to be doing functional substitution, stuff we just did the other day. But what am I plugging in? A negative x into everything that's in that function. So up here, so wherever there's x's, I'm taking the x out, and I'm plugging in a negative x. Does that make sense? And what I'm going to do is I'm going to simplify that problem down. So if I simplify this down, what happens when I square this? It becomes positive, right? It's positive x, and it's squared, right? Because you square it with -1, you square the x because it's a number. So that's x squared, positive. And then the 4 didn't change because there's nothing on the 4. So what do you notice about what happened when I simplified it? It's exactly the same as the original function, right? So it makes it symmetric. Because what it's literally telling you is that when I plug in negative numbers, they'll turn out to be exactly the same as the positive numbers did, the original function. So negative numbers and positive numbers will give you the same result. That's what it's telling you. That's y-axis symmetry. Okay, typically, here's how I can see it really easily. Like when I look at that function. All the powers on your variables, every power in the variable, they're all even numbers. Like powers of 2s, powers of 4s, powers of 6s. That will make it symmetric because So it'll stay the exact same answers. That's how you get symmetry. In fact, that graph would actually be almost really close to this. I just put a negative out front. That's all I have to do to make it actually look like that picture. Okay, do we understand y-axis symmetry? Like the idea behind it, graphically and analytically with the actual equation? Okay, now let's talk about odd functions. Over here. Symmetry. We're going to talk about an odd function now, or what they call origin symmetric. The book refers to it as origin symmetric. This is where the graph is literally polar opposites across the origin. Polar opposites. So let me give you a picture here of something that is odd symmetric. Actually, I think I have it here. So this isn't even, that's a y-axis symmetry. That one's neither. There's an odd symmetric function. As I go left and right, they're giving me the exact opposite answers. So as I go this way, and I give you like the number, if I give you the number 1.5, it was up here. What was that number? It was a 3.5. If I pick negative 1.5, it gives me negative 3.5. They're complete polar opposites. That's what makes it odd symmetry. It's balanced across the origin. Okay? So it has to be centered on the origin, that type of thing. That's what makes it odd symmetry. Odd symmetric function. That's what the graph looks like. So it doesn't matter how your picture looks. It could look like this. But this is odd symmetry. Across the origin. Graph going to the right, graph going to the left are complete polar opposites as you go. Make sense? It could look like that. It could look like this. They're complete polar opposites. As they go this direction, the answers over here are the opposite. Negative versus positive. That's what makes it odd. So that's the graphically how you can look at that. Okay, now how do we test it? Like how do you do that symmetry test? So let me give you an idea here. So g of x is going to be, I'll just make up something here. G of x is going to be x to the third plus x to the fifth. Let's say that's my function, right? Some formula. I do the exact same test. I take and I plug in a negative x into it. Plug a negative x in, and I'm gonna simplify it, see what it looks like. So, if I plug a negative x in, so I'm gonna take out the variable, and I'm gonna plug in the negative x in there. I'm gonna take out the variable here and plug the negative x in. Now, what happens when I put a power of 3 on this parenthesis? Stays negative, right? It actually stays negative, so there's actually a negative 1 up front. Because when you cube it, it holds negative signs. What about the power of 5? It stays negative, so this is what we have. In fact, if you don't want to put ones there, it's fine. It's not a big deal. I just like to show you what the number is. Now, notice this. Look at this function now compared to the original. It's a complete opposite. It's a perfect opposite. Everything is different. Not just one item, everything is different. That is odd symmetry. That's what would give you this type of graph, where the graph to the right and the left will be doing something amazing. They're opposites. Okay. Question?
Okay, so let's say on the test you ask us whether it's an odd or even symmetry. Do you want us to use the function? Can we just look at it?
If you have the graph, do the graph. Like I can look at it and go, oh, it's definitely odd. Okay. Now, if you don't have the picture,
then you can
do a little simple formula. Something easy. Now, here's your question. This is my last problem today. My last example. So I'm going to give you just a function here. Okay. So, even, odd. Which one? Neither. Neither. The reason why, I go back to the rules I kind of taught you. even functions, you have to have some even number for powers on your variables. That makes it even, right? Odd, you have to have odd powers on your variables. This is a mix of both of them. I have a power 2 and a power 1. It would give me nothing. This would not be symmetric if you actually look at it. So, because if I do the negative, the negative x test, the actual symmetry test, it will not turn out to be a perfect opposite, and it will not be the same thing you started with either. Because what will happen here, this power 2 will cancel out the negative sign. The negative sign will actually stay in the middle, and then the negative 2 didn't even change at all. And is this the exact same thing you started with? No, and it's not even the exact opposite of what you started with either. The opposite would have been negative, negative, positive. So, at this point, that problem is neither. Because when you look at the graph, it'll look something like, it won't look like this, but it'll mimic something like this, where it's just not balanced. The things on the left side and the right side are not even close to being the same answers across the y-axis and across the origin. They're not. Like if I plug in the number 1 here, it will not give me the opposite at negative 1. They're not even close. You can see them. They're not even the same digits. That's the idea. Okay, do we understand neithers now, like how the graphs work? Okay, we'll practice this more tomorrow. I just want to give you the kind of the rough introduction today. Again, tomorrow we'll talk about slope and how that all applies to everything that we've been talking about. The slope can kind of give it away too. Okay. The rest of the time you have about 10 minutes or so. You can work on your homework. I'm going to hand out some papers for those who were gone yesterday. Grades are up to date. Check your grade online. See what you're missing. Now, if you're missing an assignment, like in the grade book, it says an LI, it's missing, late. Get it turned in so I can grade it. Okay? Also, if you don't know what the page numbers are, because in JMC it's very limiting. I can only type in like 10 characters long. If you need to know what the assignment is, go to my website and you can see what the full assignment numbers are like this. Because the JMC will not allow me to type more than like 10 or 12 characters. So, that's more than 12 characters with the numbers there. So it's what I always put at the end is like et cetera, et cetera, et cetera.
I got a good idea.
This research has like paragraphs for us.
Mine has like 10 characters. And then it cuts me off. So, yeah, I try everything, and it won't let me go past 10 characters. It cuts me off, and it won't let me type anymore.
Or have you tried editing the HTML and then submitting it?
Never. I have not. So, I think I'm just going to have to write.
Just hack JMC.
Alright. But there you go. You can go ahead, you can move around, you can work on whatever you need to.
Can I grab some ID from the office?
Yes, ma'am. I'm going to hand out some papers here. So again, if you're getting a paper back and you noticed it was missing in the JMC, just hand it back to me. I make simple errors every now and then. But if you want to redo something, please redo it. Fix it. Make fixes. Turn back in. And let's get off our cell phone. That'd be great. Yes. Domain range, domain of the X numbers, range of the Y numbers. So it's the range of like 4 R words. Like 4 R words. X is 1. Yeah. Cross country runners, good luck tonight. They can meet tonight. Good luck. This guy's Angel tonight, correct?
Yeah.
Yes. Okay. I'll get my date tomorrow. Overman.
We can still turn.
Boy, resubmit stuff, yeah, until tomorrow afternoon.
Can you redo our
Oh, yeah.
test?
Yeah, there you go. Yeah, just talking about sample.
Mr. Wood? Good question.
Yes.
Like, both these?
I don't know.
Like,
Are we not allowed to?
I got wrong, but then it's.
Oh,
But okay.
If you return it.
Oh, these are ones we.
If you return it, I was preferencing. So that way you kind of know when you look at. Oh yeah, I already did it.
Oh, we have a vocab test. Huh?
I practiced 3 times last night.
I was gonna take 5 seconds.
It couldn't get any bad losses, but
You know, it's
what's this?
it's not resting.
I know how to do it. Really?
It's not resting. What's that hard to make sure to see it?
I always make mistakes because when I get them, I just sing in a big pile and I grade them all at the same time. So, and then I always tell them like I got to read them.
When you just got what do you say?
Well, we have a vocab test today at lunch.
Wait, no.
Yeah. Hey, you want to turn back in? I was wondering, like, where's the second page?
It's not there, right?
Hey, you never came
Oh,
through.
no, no.
Never came through last night.
Still look at you weird.
You never came through last night.
You were where?
Working.
Let me reprint on.
Yeah, we ate half of the bag. We ate half of the 90 bag. 3/4 of it. Wait, one bag was 90? Yeah, he brought a 90 bag, 40 bag, and half of it. We had a ton. We made like 40 of them. Everyone was like, oh, we're so hungry. These are really cheap today.
Oh, look at all your
We ate a tray. We ate one tray. That's good.
He's actually both has correct.
He would have came. He still have a tray. Because Jack, I went to Dane's house before. His parents literally like forced me. Like they're like, "You want some food?" I'm like, "No, I'm good." Like, "No, you have some." I'm like, "All right."
Why?
And then they're Jack. And then they're offering Alex food. And then Dane's like, "Alex can't do it." They're like, "Why?" He's like, "Because our food's pretty nice." Like, oh. Isn't this John?
I think no.
There can be
Someone will tell her. I don't want to use that.
No.
Oh, when like when you're doing like when you're writing out the numbers, don't put doubles in domain of range.
Yeah, but like there can be a fraction.
Oh, range numbers can't have a double. Like, or like what I mean is like when you have like your X number, you can't have like 2 answers to that. Does that make sense? Okay, these little track.
Wait, how long these been on?
Wait,
4 hours? It's been like an hour and a half. I got
I don't have one. I don't have a single set off. Why? It's been my phone. And then I come back to
Oh, wait a minute. Good.
and then I'll be up to like 2 again.
Reason again.
I go to work after school. $20.
That's pretty easy.
You just walk up and like, I'm
I got the quiz.
Yeah, you did.
What? I never know what's right.
Okay, so Spencer and Spencer, you guys were the only ones that were here.
Yeah, I know.
Yep. And also on Genesee, my first test. I'm so
Did I hand it back to you? Alright, you're not hand it back. I regraded it, correct?
You're like,
Yeah. No, I don't want to.
someone else is
I don't want to.
somehow I have to class right now and I don't
Tell me that number.
Taylor, everyone else says they understand, just so they all seem to know. I can guarantee no one understands. Yeah, just
That's the type of thing.
no one can know.
Yeah, that definitely helps.
After this,
Alright, yeah. That's definitely a good thing. Alright.
what did she say? I don't
I
know.
got
You
it.
guys said Nintendo, so I don't
You
know.
kind of set the.
Oh.
Hello, hello.
Oh, goodbye.
Oh, back.
Yep.
Tomorrow?
Paige, I got your emails.
Yeah, I know for sure.